Welcome back to P1. Today we're looking at areas of sectors and segments, which is unit 7.3. So let's first talk about a sector. Now, a sector of a circle is kind of like a pizza slice, and this would be the area of the sector. Now, technically this is the area of the minor sector, and the large part would be the area of the major sector. And it's quite important just to understand those words and what they mean. So let's get back to the normal diagram. So we got R as a radius there, theta or R as a radius there, and this will be the area that we're going to focus on. And as I said, this is the minor sector, but it'll be the same formula for the major sector. We just be looking at this angle here. And it's quite a nice formula to use. It's just A equals 1/2 R squared theta. Nice and straightforward. So a quick little example. So in this diagram, we have the area of the minor sector and the angle of that minor sector, and we want to find the value of R, the radius. So the first thing I want to do is put my formula down. So remember, you always put your formula down because it helps you remember it. By the end of doing all these practice questions, this formula will be locked in your head. So what we want to do once we've done the formula is always put in everything we know. And there we have it. So we can find out what R squared is. And this is 38.69 to 2 decimal places. And then finding R, we get 6.2 centimeters here to 1 decimal place. Easy, straightforward. Okay, now what we'll do is we'll have a look at what a segment is and how we find that. Okay, let's have a look at what a segment is. So segment is part of our sector. So if you think here, our sector is this pizza shape. Okay, now with a segment, what I want to do is I'm going to join two of my points together. So I'm going to call them A and B, but I'll join them together there. So let's call this one A and this one B, and O there. And that is a segment here. So this area here, that is your segment. Area of segment. Okay, so it's that little sliver of area. Now, how do we go about working it out? Well, we know how to work out the area of a sector, and we actually know how to work out the area of this triangle. Now, if you remember back, so let me just put down area of the sector is 1/2 R squared theta. So this is the sector OAB. Now the area of a triangle, if you remember, is 1/2 AB sine C. Okay, so triangle. Now in this case, A and B are both radiuses. Yeah, it's two sides and the angle in between them. So the two sides are both radiuses. So it's R times R, so R squared sine theta. Okay, so this is now my triangle OAB. And to find that little sliver of area, the segment, we want to take them away from each other. So area of segment would be the area of the sector, half r squared theta, minus the area of the triangle, half r squared sine theta. So what I'm doing is the area of this pizza slice, imagine it that, take this triangle out of it, and then we're left with this area. And that's what we're doing. Now you can see that actually there's a half r squared in both of them. So I can factorize that out to make my life easier. So half r squared theta minus sine theta. And that is then the formula for area of a segment. So remember, area of a sector, area of a triangle within this circle, we'll be using r squared instead of a and b, and then area of our segment to jump straight into it. Obviously, if you've already worked out a triangle and a sector from one part of a question or another part of a question, you can just take them away. Nice and easy. Let's have a look at one example with this. Okay, straightforward example. So remember the formula, writing it down like I've said always helps. So theta minus sine theta in brackets. And remember, we want our calculators in radians for this. So radius is 6 squared, theta is 1.1, and at this point then we can go to our calculators and we get 3.76 centimeters squared. Okay, let's have a look at part A here. So we want to find the area of the major arc here. So this angle is going to be 2 pi minus 0.9. And then don't forget my formula is area equals half r squared theta. So we've got a half times 7 squared times whatever 2 pi minus 0.9 is. And we have an area of 131.9 centimeters squared. Now, looking at part B, nice straightforward one, area of a segment. So half r squared theta minus sine theta. So half times 5 squared times 1.2 minus sine of 1.2. And don't forget to have your calculator in radian mode. So we get 3.35. And then part C, so first I got to realise, well, 6 is the radius, this is also a radius here, so we've got 6, 6 and 6, which means we've got an equilateral triangle. That means each angle is 60 degrees or pi by 3 radians. That means then I can find this angle here. They're on a straight line, which means they've got to add up to 180 or pi radians, so this must be 2 pi by 3. Now that I've got that, it's nice and straightforward. So my formula is a half r squared theta, because it's a sector. So we got half times 6 squared times 2 pi over 3. And this is 12 pi centimeters squared, which is nice if it does want it in terms of pi, or if it wants it as a decimal. We got 37.7 centimeters squared to 3 significant figures there. So what I would do here, very quick sketch. Just pop in my values on here. We've got radius 9, an arc length of 7, and we want to find the area of the minor sector. So this area here. Now we need that angle. So if I think back to the previous video, L equals R theta. We know that L is 7, R is 9. Therefore theta is 7 over 9. Now that I've got that, I can go ahead and find the area of the sector, and that's a half R squared theta. So half times 9 squared times 7 over 9. And we get 31.5 centimeters squared. So, and this one again, let's just do a very, very rough sketch. So we've got 100 centimeters squared as the area, and we've got a radius here of 10, and we need to find the perimeter. So that means we actually just need this arc length here, and to find the arc length we're going to need this angle theta. Okay, so let's look at the area of the sector, as that's what we're given. So the area is 100, the radius is 10, and obviously we don't know what theta is yet. So 10 squared is 100, half of 100 is 50. So you can see this is nice and easy, so theta is going to be 2. Now arc length, if I call this A and B, that's what we're finding, is going to be R theta. So the arc length AB is going to be 10 times 2, which is 20 centimeters. Therefore the perimeter is going to be 2 10s and my 20, so 40 centimeters in total. So looking through the question on this one, we get a few additional pieces that we need to think about. Radius of 12 centimeters, and then we know that OA and OD is 7. So OA, this is 7, OD, this is 7. It has a radius of 12, so this AB must be 5 and DC must also be 5. Okay, because obviously 7 plus 5 is 12. We've got that angle 1.8, and then we need to find this shaded section. So in this one, it's a little bit different to some of the others, because in this one, it's not a segment. We're not going with the same radius here. Okay, so we can't just jump in with the area of the segment formula, because they don't have the same radius. So what we do need to do is do them separately. So let's look at the sector OBC first. And the area of this is going to be a half R squared theta, which is a half times 12 squared times 1.8. Remember that full radius there is 12. And this gives me 129.6 centimeters squared there. Next we need to think about this triangle. So the triangle OAD. And the area of a triangle is half AB sine C. Or remember, in our kind of case, it's like half radius squared times C in a way. But this radius is a little bit different, so I'm just going to stick with using AB. A and B are both going to be 7, so half times 7 times 7 times sine of 1.8. And this gives me 23.9 centimeters squared. Now, I need to make sure that I keep the full value into my calculator, as while this one's exact, this one's rounded. Okay, so area of shaded section, and that's going to equal area of sector minus area of triangle, which in this case is 129.6 minus 23.9. Remember to use the full values, and that gives me 105.7 centimeters squared. So this one's an old exam paper from back in 2006, January paper, and it's worth 8 marks in total. So part A says show that cos AOB equals 7 over 25. So AOB is this angle here. I'm just going to call it theta. And if I think back now, I've got a triangle here where I know 3 sides and I want to find an angle. So this is the cosine rule. So we're looking at basically a squared equals b squared plus c squared minus 2bc cos A. Now I'm going to use the rearranged version. So cos theta is going to be equal to b squared plus c squared minus a squared over 2bc. Now b squared and c squared are going to be my 5s, because the a squared is always opposite that angle. So that's the 6. So cos theta equals, and we get 14 on the top, 50 on the bottom. Therefore we can see that cos theta is going to be 7 over 25. Part B is nice and easy. We just need to find out theta. So in radians in my calculator, I want the inverse cos of 7 over 25. So this is 1.287 radians. But I'll still store that full value in my calculator. Now part C is calculate the area of the sector. So again, nice and easy, put the formula down, half r squared theta. So we got half times 5 squared times by 1.287. But of course I'm going to use the full value. And that will give me 16.1 centimeters squared. And again, I'll always store this in case I need it. Now for the final question here, I've got 2 options. It does say hence, as if that's a little bit easier, but in this case it's a segment that we're finding, so it's pretty much easy to use the segment formula. So using the segment formula, I would have a half r squared theta minus sine theta. So that's a half times 5 squared times 1.287 minus sine of 1.287. And I get 4.088. Or if we're going to do this to 3 significant figures, let's go 4.09 centimeters squared. Now, if you did want to use your answer to part C, you could have just found the area of the triangle. So I'll do it that way as well. Area of the triangle is a half AB sine C. So it's the half times 5 times 5 times sine 1.287. And that actually gives me an exact answer of 12 centimeters squared. So I can see that the area of my shaded region is that 16.1 minus my 12, which is 4.1 centimeters squared. And that's obviously the rounded answer because I rounded up here. Okay, if I took this one to the extra decimal places, these two would be exact. Okay, and that's it for that question. Final question is another past exam paper question. This particular one is from June 2011, so it's, again, it's another old one before the changes, but this type of question, very similar to this, I've actually seen show up multiple times, so that's why I wanted to put it in here. So in this one, we want to find the shaded region. That means we basically want to do the area of the sector minus the area of the circle. And we have a bit of a problem. We can find the area of the sector very easily, but the circle is a little bit harder to find because we don't have a radius. So let's first just get started with the area of the sector so that we can get that one done out of the way. So area of sector, and that's going to be a half r squared theta. So half times 6 squared times pi by 3. And that gives me 6 pi. Now, when I'm doing a question like this, even if the question wants me to leave it in decimals at the end, to 3 significant figures or 2 decimal places, whatever it might ask, I'll still leave it in terms of pi if I have that option during the question, because that makes my life easier. Now, next step is to work out some stuff with the circle. So let's take a straight line down, and I'm actually just going to take it into the center of this circle. I'll put some dashes just to show it following all the way down, but just to the center of the circle is what I'm thinking of right now. Because the center of a circle to a tangent is going to make a 90-degree angle, and that is what's going to help me solve this problem. So that's a 90-degree angle because that circle just touches the side OB. Of course, I could do this on the side OA as well. Now, this angle is going to be half the size, so it's pi by 6, and I'm going to call the radius of the circle r. What that means is this dashed line is also going to be r because it's coming off the same center. This whole line from O all the way down, let's call this T. So O down to T is going to be 6 because it's going to be a big radius. So O to C is going to be 6 minus R. So this side here is 6 minus R. Okay, now what I can do is I can think of trigonometry. Opposite, hypotenuse. Okay, I'll pop that in red. Opposite here, and the hypotenuse of that triangle. So we're actually looking at sine, aren't we? Sine pi by 6 is opposite, which is r, over the hypotenuse, which is 6 minus r. Now, pi by 6, or sine of pi by 6, I should say, is a half. And then let's rearrange, multiply up by the 6 minus r, and multiply up by the 2. Then add in r to both sides, we get 3r equals 6. Therefore, r is 2 centimeters. Now that I know the radius of the circle, I can find the area of that circle. Because the area of a circle is, of course, pi r squared. So radius is 2, so that's pi times 2 squared. So the area of that circle is going to be 4 pi. Therefore, shaded area is going to be sector minus the circle. Sector is 6 pi, circle is 4 pi, so I get 2 pi centimeters squared as the shaded area. Or to 3 significant figures, this would be 6.28 centimeters squared. Hopefully you found this video useful. As always, if you did, show some love, hit that like button, and if you're here and you've been coming back and forth but you haven't subscribed yet, hit the subscribe button and join the rest of us in the community. See you next time.